2.6 chain rule, example 4. A lot of these example 5. A lot of these are going to look very similar. Yes, please do. Yeah. For each of the following, rewrite if necessary, and then find f prime, and then simplify. All right. F of x equals cosine of 5x squared. What is the angle? Is it 5? Is it x squared? Is it 5x squared? Is it just 5x? How do we interpret that? Will we interpret it like this? Or do we interpret it like this? I think that's right, yeah. So in general, if you don't have parentheses after a trig function, it's by default the entire first term is the angle. So if you would have had something like 5x squared plus 1, we would still interpret it like this. Yes, yes? Okay, good. So adding grouping symbols then that aren't there can help you actually see layers. So this is 2 layers. You got a cosine of blob, and then you have an inside function. So 2 functions, 2 layers, 2 links in the chain. Here we go. F prime of x equals, working from the outside in, what's the derivative of cosine of blob? Negative sine of the blob. And again, remember, you don't take the derivative of the blob just yet. Times, there's that little link in the chain, times the derivative of 5x squared, which is 10x, in parentheses or not. And now it's just a matter of simplifying. You can bring the 10x in front times the negative 1 that's there, and you get negative 10x sine of 5x squared. And that's it. That would be the function that gives you the slope of f of x at any x value. That was a nice, easy one to start with. Letter B. Now the parentheses are there, so if the parentheses are there, we take them as they are. This is f of x equals cosine of 5 times x squared. What rule is this going to require? Is this a chain rule? Product rule? You could use a product rule. You could do it like that. Let's try the product rule. 2 factors, 2 terms, right? What's the derivative of cosine of 5? You got to be careful here. If you say it's negative sine of 5, there's nothing wrong with that. But then you have to think of it as being a chain rule. It's negative sine of blob times the derivative of blob. What's the derivative of 5? 0 times the second one goes along for the ride. So here's the easier way to do it. Just recognize that cosine of 5 is just a what, Austin? It's just a constant with a k. Nice. It's just a number. Is it positive or negative? Where does 5 radians live? Yeah, it's going to be like this is pi, right? What's 3 pi halves equal to? It's a little bit 4 points. So cosine of 5, it probably makes it over here in the quadrant 4, right? 5 radians. So it's going to be some positive or negative number? It's just some positive number. Yeah, some positive number times x squared. So really, we could do the product rule, but its derivative would be 0. So remember, constant multiples go along for the ride. So you can just use the power rule here, right? So it would be 2 times cosine of 5 times x. Now, if you write it like that, that could be a little bit ambiguous, right? So what are we going to do to help it out? You either put parentheses around the constant, or feel free to do this as well, whatever you prefer. It just kind of separates it. I kind of like the first version better. That's how it was given. Oh, yeah, you could do 2x cosine of 5. That's not bad. That kind of eliminates the need for parentheses. And we don't see that very often where we split up our constant multiples on either side of a variable, but it does have a nice, efficient feel to it. Yeah, I like that. Yeah, good job. Good job. Can we call it 5 cosine of 2x? No, it's not a shell game, right? You can't really do that. Okay. What if we jumble the letters? SOC, sock, of x to 25. No, that's alphabet numeric soup. Alphanumeric soup. Okay. Anyway, try to keep me on task, everybody. Here we go. Letter C. I'm going to let you handle this one. On your mark, get set, go. Huh. Did you? Yeah, I'm kind of expecting an important update today, so I apologize. I have my phone alert turned on. That was the Sports Center alert saying Steve Spurrier retired, but that's old news already. College football is going to miss that kind of acerbic wit. All right, how many layers do you see here? I see 3. If you see a squared like this, and this is important to say something about here, your calculator, the way your calculator is programmed, if you actually physically typed in something into your calculator like that, your calculator reads that as cosine of 5x quantity squared, which is the same as cosine squared of 5x. But that's just your calculator's deficient programming language. That's not how you would read this outside of a calculator, and I wish that they would fix that, but I think so many students are aware of that it would mess them up if they fixed it. This is really cosine of 5x, the angle squared. The angle is what's being squared. So there's a subtle difference between, and by the way, you could type it into your calculator like this, and just for good measure, it will accept that as well. So just be aware of that. So yeah, working from the outside in now, the derivative of cosine of blob is negative sine of the blob times the next layer is blob squared. Kind of interesting. So that would be 2 times blob to the first times the derivative of the innermost blob is a 5. Now this is just one way to do this problem. We'll see another way here shortly. If I then combine all of these little factors and the negative in the front, I end up with negative, 50? X times sine of 5x quantity squared. And that kind of preserves the original angle in quantity 5x squared. The other way to do it, in the spirit of simplifying early and often, 5x quantity squared is actually equal to what? 25x squared. So if you do that, there's nothing wrong with that. That actually eliminates a whole layer, right? So now we just have cosine on the outside and 25x squared on the inside. You should end up with the same answer, but one fewer factor. So now f prime would be negative. And here's what you could do if you anticipated, of course. You could say it's going to be negative, leave a space, sine of blob, and then times the chain rule, the derivative of the blob is 50x. And then you don't have to rewrite it. And that's the same thing we got above here, except the angle now looks different, a little bit different. So if you can eliminate a layer, that's good practice. So doing it both ways is important too, because maybe a free response question, it doesn't matter. But on multiple choice, your final answer looks more like that rather than like that. And it's not a very difficult thing in this case to like refactor that as 5x quantity squared. But anyway, you're going to see that there's multiple ways to do it. Okay, letter D. Letter D. Did they fix it? Yep. Really? Huh. It wasn't turning on at all? No, sir. Wow. How many layers do you see here? 3, right. So you got the condensed notation. So perhaps in the future, the near future, if not already, you might not have to rewrite it, but in the beginning it's helpful. You have your blob squared, you have your cosine of blob, and then you have your innermost blob of 5x. So there's your 3 layers. Working from the outside in then, blob squared becomes 2 blob to the first. And that's cosine of 5x. Times the next layer, the derivative of cosine of blob is negative sine of the blob. And again, what's my opinion on dot negative? I don't like it. I've seen too many students make careless mistakes, so put parentheses. And then times the innermost layer, the derivative of 5x, which is 5. Now there's a couple of ways to simplify that. The first way would be to combine your constant multiples. You got a 2, a negative 1, and a 5. That gives you a negative 10. I'm going to go ahead and flip this and call it sine of 5x times cosine of 5x. That's one way to do it. And that's not bad. But you should also identify, if you rewrote it like this, 2 sine of 5x times cosine of 5x, and then that negative 1 and the 5 just get together and call it negative 5, then this is equal to what? 2 sine of blob cosine of blob is your double angle identity for sine. And that is one that you need to know. We've seen it a couple times already. So it doesn't have to be x, right? 2 sine of blob cosine of blob is equal to sine of twice the blob. Our blob is 5x, right? So we can simplify the highlighted part in blue as sine of twice 5x, which is 10x. And then, of course, times the negative 5, you could bring that in front. When would you need to do that? Well, you would have the option on a free response. You're working with one trig function now instead of 2, if we set it equal to 0. But the angle's bigger. That's the trade-off. Or multiple choice answers trying to match it up. So the double angle identities you need to know. All right, any one of these would be great. All right, letter F. What should we do first here? Rewrite it. Good. So you know you have to get rid of the radical. So you can leave it like this. Maybe add parentheses around the 5x, and it's to the 1/2 power. Now, as it's written, we can proceed using what rule? The quotient rule. But because we have a constant in the top, d high is going to be 0. It's probably going to be a little bit more efficient to just bring it to the top and say it's cosine of 5x to the negative 1/2 power. And the chain rule is a little bit faster. But notice that's still just f of x. I haven't taken the derivative yet. When you take the derivative now, you call it f prime on the left, and then 3 layers, right? Y'all see the 3 layers? Blob to the 1/2 cosine of blob, and then 5x. So negative 1/2 blob to the what power? Negative 1/2 minus 1 is negative 3/2. Good. And then we just write down the inside function. Times. The next layer is cosine of blob, and its derivative is negative sine of the blob, times the innermost layer is 5x, and its derivative is 5. And technically, you're done with the calculus again. It didn't last that long. But we can clean it up now. We got a negative 1/2 times the negative sign. That's going to make it a positive. I do have a 5 in the top. I have a sine of 5x in the top. And in the bottom, I can throw the 2 from the 1/2 as a factor down there. And then, of course, the middle or the cosine factor is to the negative power. So it can go back to the denominator. The 3/2 power would make it the square root of cosine cubed of 5x. And again, in the condensed notation, you can write the cubed between the trig function and the angle. So that would be the kind of nice cleaned up version of that. Well, notice what I did with the 2. I brought the 2 down there, so it is still effectively a 5/2. And it's only because it's all one big term. So you can, whenever you see like a negative exponent in a term, you can kind of just build the shelf. Build that division bar, and then stack factors on the top and stack factors on the bottom. Kind of a nice way to do it. It's hard to stack things in the numerator if you don't have the shelf built, right? Build the shelf first. All right. I'll let you do this one. Done? What is it? 0. Now be careful. If you just write that down, how's that? Cosine of 5, we already said, is a number, positive number, right? But if you just write down 0, it's just like, are you starting to do a piece of art? Are you starting a drawing and you didn't finish it? Did you watch The Walking Dead on Sunday night? It was an hour and a half instead of an hour. I wasn't ready for that. Right? Oh. Okay, so when you write down 0, we don't know what you're doing. We have no idea what you're doing. What should we write instead of just 0? F prime of x equals 0. Now we know what you're doing. Okay, good. Notation. What's the third one? Notation. Location. Calculus. Okay. I'm not sure if there's a wrong answer to that. Calculus, notation, location. Right, good. You don't want to put the answer with the correct notation, for letter F over here on letter A. So it's calculus, notation, location. Location. Yeah, I like that. Okay, great. Come up with new stuff. Very good. You don't want to be writing these answers either on your AP history test or English test either. Although there is no better way to spice up an English essay than to throw in a couple of math formulas. It makes the reading. Most people, or some study I read years ago, if they want to read something and they see any math formulas in it, most people kind of just like, I'm not going to read that. Right? That's just I'm not going to understand it, and it's not going to have like a rising action or character development or any kind of climax. No denouement for me. None of that. I'm out. Example 6. I'm going to let you do this one. Find the equation of the tangent line to this graph at pi. At pi. Well done? Nice. Cool. All right, what do we need for the equation of a line? 2 things, right? Slope and a point. It's a little 2-ingredient thing, right? So the slope is going to be f prime of pi, and the point is going to be pi comma f of pi. So let's go ahead and find the point first since they gave us f of x. It's pi comma, and we'll go ahead and evaluate it from the unit circle because it's so much fun. Unit circle time is one of my favorite times. If I plug in a pi, I get sine of pi, which of course is 0. Okay, so that term's gone, sweet. And then cosine of 2 pi, oh, tricky. What's cosine of 2 pi? 1. So I have 0 plus 1, which is 1. So we're at the ordered pair pi comma 1. We have our first necessary ingredient in this 2-ingredient thing. Now I need the slope. But before I can find f prime of pi, I got to find f prime of x. Okay. So I got 2 terms. The derivative of 2 times sine is 2 cosine of x, right? The second one's going to require the what rule? Because it's not cosine of x? Yeah, chain rule, because it's cosine of the blob. So that's going to be negative sine of 2x, and then times the chain rule, the derivative of 2x, which is 2. And notice I left a space in the front, so I wouldn't have to rewrite it. You don't have to do that, but again, notation, notation, notation. Now, instead of simplifying it, if that could be done, maybe with an identity or combining like terms, I might just go straight for plugging in pi, because I'm just after the numeric answer. So we'll do this one together. Cosine of pi is negative 1, right? Times that 2 makes it negative 2. And then sine of 2 pi, 0. So it's going to be negative 2 minus 0, or just negative 2. So there we have our slope, and we have our point. So the equation of the, did it ask for the tangent or the normal? The tangent line. So we have the tangent slope. In Taylor form, it's just y equals 1 minus 2 times x minus pi. What would the slope of the normal line be at the same point? Positive 1/2. Good. Positive 1/2. Opposite reciprocal. All right. Nothing to it. Nothing to it. Number 7. Suppose that the differentiable functions f and g and their derivatives have the following values at 2 and 3. Hang on. Hang on. They're telling us that both f and g are differentiable. Where are they differentiable? Everywhere, right? Anywhere you take them, they're differentiable, and for all values of x also as well, right? And that means that they're also what? Everywhere. Continuous. Okay, that comes for free. That's nice. So we have selected choice cuts here from f and g and their derivatives. Evaluate the derivatives with respect to x for the following combinations. So this is kind of like we did in the warm-up. I want to find the derivative of this function at x equals 2. So there's a couple of ways to use proper notation here. You could throw in front, oops, not with a highlighter though, you can put in front of there d dx if you want to do it like that. But I think it might be easier if we just label all of these y equals. So we don't, because the d dx notation is a little bit cumbersome. So let's just call it y equals. All right, so now we got y prime equals 2 times, we have f of blob. What's the derivative of f of blob? F prime of the blob. Now 3x halves is the same as 3 halves times x. Yes, yes? Are you okay with that? And then times the derivative of the blob, the chain rule, what's the derivative of 3 halves x? 3 over 2. So this is kind of like we did in the warm-up. We're taking the derivative of functions by their notation only, not actual expressions. If you simplify that, you get a 2 times the 3 halves. That gives you a 3 times f prime of 3 halves x. Now we can evaluate it at 2. And this is what another reason setting it equal to y is nice. We can just say y prime of 2. We can kind of use the function notation there. And we get 3 times f prime of. Now when I plug in a 2 for x, what do I get on the inside? A 3. And now on a free response, we could not stop there because that's not numeric, but hopefully, fingers crossed, f prime of 3 is going to be up there. What is f prime of 3? 2 pi. Good. So we end up with 2 pi. Now there you could stop on a free response, but of course the multiple choice answer would be 6 pi. Got it? See how it's done? All right, go ahead and see if you can rattle off the rest of these B, C, D, E, F, G, and H on your own. Yeah, because it's the same idea. I'm going to go ahead and work them along with you quietly in the background so we can maybe compare answers. On the last one, um, I divided out a 2. Oh. I'm sorry, where? Here? Oh, does that not work? Oh, I wrote the 2 in the bottom. You're right, yeah. And that's not how I normally do it because I usually make a careless mistake, but I didn't want to write it all again. Man, y'all caught that. Very good. And I was actually in a zone working that one. So this 2 should not be there because it divided out. That 2 should not be there. That should be a 3 and a 3. Nice. And then that would be still a 10. We can still do that, right? Thank you. Careless mistakes are easy to make. 10/64? Yes, that simplifies to, yeah, that last one was a little bit tricky. It's even really hard. It's not fun on an iPad either when you have to keep scrolling up and down to get values out of a table. But when you have them right in front of you, you can kind of stay in the zone a little bit. Let's compare some of the answers just to see if we're all on the same page, because it's real easy to make a mistake. The first one here we did together, 6 pi. The second one, that was pretty straightforward, right? 2 terms, the derivative, you can plug in. Let's talk about the notation as well. If you're calling it y, it's really nice, y prime. You don't need to put the of x if you're doing the prime notation. You could just say y prime equals f prime plus g. You do want to show that you're plugging in a 3. So if you say y prime of 3, I like to put f prime of 3 plus g prime of 3. But you could skip that step and go straight to here if you can pull the values out of the table. Now, here's the thing. If you don't write this line here, then what you show here on a free response should kind of show the values that you pulled from the table. Now, there we're going to stop because they're not like terms, so we can't really add them. You want to always indicate what you're doing either numerically or symbolically. You can always have both. All right, on part C, that was a product rule, so calling it y. Notice on the next line I have f prime g plus fg prime. That's just without the of x's. Then if you put y prime of 3, you could go straight to this second line here. If you have the table in front of you, it's a lot easier to do. Having to scroll up and down again, that's just the iPad, I guess. And of course, on a free response, you could stop on the line right above the highlighted one, 15 minus 8 pi or negative 8 pi plus 15. Y'all get that? Okay, good. Product rule. This becomes a little bit tedious at some point. This one's going to be the quotient rule, the Hody-High rule. So again, you could eliminate a little bit of clutter by just forsaking the of x part, gf prime minus fg prime over g squared. And what I did on this one, instead of writing like g of 2, f prime of 2, I did y prime of 2, and I went ahead and pulled the values right out of the table. I knew it was going to be g of 2, so I have it shown right there. I know it's going to be f prime. I have it shown there. So this would be indicating your answer numerically right here. And on a free response, you don't have to simplify that answer. It's numeric. Okay? But of course, if we keep going, you end up with a complex fraction. So multiplying by 3 over 3, 74 12, 37 6. Anyone else get that? You got that? Lots of little potential for little things. Just pulling the wrong value out of the table can happen. You did Heidi Ho minus Hody High? Oh my gosh, no. It's dyslexic Wilson, right? Hody High, not Heidi Ho. You start with a ho and you end with a ho, Brandon. Okay, so you got the opposite. You got negative 37.6? Yeah. I don't know how to be more wrong than to be the opposite of correct. So, yeah, subtraction is not commutative. Hody High, say it, Hody High. Hody hi. I'll try and greet you when you come in every day. Hody hi. And you answer minus Heidi ho, and we'll have it. Okay, good. The next one. That's composition. That was like the warm-up, so hopefully that was a little more straightforward now. You got -1. Simplified nicely. Maybe you're still working on some of these. I know they were kind of arduous. Here's one where we have a numeric value or a number in the numerator, so it's a little bit faster to bring to the top. Use the chain rule. Don't forget that other little piece. Don't forget the chain rule. It's to the -3rd when you subtract. You get the new exponent, and then times the derivative of the inside function. Substitute, and you get 5/32. That's where you were at right there. Positive 5/32. Good. Letter H. This was kind of a doozy in terms of taking the derivative. Rewriting it, you have the whole quantities to the 1/2 power. But inside, f squared x, d squared of x, those are written as f of x squared. And notice I have parentheses around the entire f of x. If you just put f close parentheses of x squared, that's kind of like the calculator notation. So this kind of helps you see the symbol. So now working from the outside in, we get 1/2 blob to the -1/2. Don't forget that exponent. Times, I switched flavors here. Now inside, you're going to go and multiply by the derivative of that. I know it's 2 terms, so I'm going to generate 2 terms. So this first open purple parentheses is very important, maybe even important enough to put a beefy bracket. Now the first term is blob squared. You have to unpack the boxes as you get to them. So the derivative of blob squared is 2 blob to the first. Now, before I move on to the next term, I have to unpack that box that has an f of x inside of it, so times its derivative f prime. Now, of course, you don't need to put f of x to the first, because anything to the first power is itself. But for inventory purposes, for record keeping, accounting purposes, it's nice to have. And then, of course, you move on to the second one, plus 2 blob to the first times the derivative of the blob is g prime. And that last purple closed parenthesis groups both of these terms times that. So then when you go to your y prime of 2, you can simplify. This purple thing is all in the numerator, so I wrote it like that. The negative exponent with the 1/2 will kick that to the bottom, and the 1/2, you can just put a factor of 2 in the bottom. And then what I normally do, and I notice there's a 2, is I actually take another line to write it. I factor out the 2, so I have 2 times blob over 2 times blob, and then, of course, they divide out. This way works as well. It's a little bit kind of uglier, and then I made a mistake there. Now you can plug in from the table 8/3 plus -6, it comes out to be. And since we have it on the green line, all clearly indicated what I'm doing, feel free to combine these in your head. 8/3 and -6. That's 2 times -3. Anyway,
this week and next week during all 3 lunches. They are $15.
keep working on it and getting rid of the complex fraction. Multiply by 3/3. Square root of 68 is not a perfect square, but how do you know that it's 4 times 17 if you don't have it memorized? Well, you know it's even, right? So it's there's a 2 factor. Half of 68 then is 34. 34 is another even number, so you know that there's another factor of 2, right? Which means that if there's 2 factors of 2, there's a factor of 4, which is a perfect square, and that leaves 17. So you can pull the 2 out, multiply by 3, get 6, and of course 10/6 is 5/3 negative, or -5 square root of 17 over 3 times 17. So whatever. Not a difficult thing, right? But very tedious. Very, very tedious. The calculus is actually the easy part, right? Hody hi minus Heidi ho over ho ho, right? And then it's all the little minutia, the tedium of plugging in and doing some algebraic maneuvers. You have to be pretty agile. Okay, any questions on those? Scroll to F. Yes, I will scroll to F. There it is. E. Oh, that is E. I was looking at the function name as f of g. There's F. There's letter F with function square root of F. I should know my alphabet better. I apologize. When you have to file things in alphabetical order and you get kind of like to the middle of the alphabet, do you kind of have to like sing the song in your head just to know? Right? You do? Yeah, you do. So, okay. All right, this comes later. I don't know. Can anyone say the alphabet backwards? Anyone know it that well? You know that you could say it backwards? Would you care to do it?
Okay. CYXWBUT
Wow. You kind of did it with a little cadence there. So did you have a teacher in elementary school that taught you like the song?
No, I was super bored one day.
You were super bored one day. Wow. Now, when you memorized it, did you have to write out the letters and then learn it backwards, or did you just visualize it backwards? Wow. That's nice. Yeah, I can't do that. I get to Z and then I get stuck. You know, when I get to Z, I have to like, what comes next? And I have to sing the whole song going forward. And I stop at the letter before Z, which is Y. So I can't do that. That's impressive. Okay, let's move on to example 8. Use the fun fact that the absolute value of x equals the square root of x squared, which reminds me I need to pass back the first 6 weeks bonus questions, because that was a really important part of that bonus. This is an identity that we're going to use. The absolute value of x is the same as the square root of x squared. And the chain rule to figure out what the derivative is with respect to x. All right, so we kind of know the answer to that. If we were really interested in what the slope is of the absolute value of x at any x value, we might not even need a function, right? Because we know the graph looks like that. What's the slope everywhere to the left of 0? -1. And what's the slope everywhere to the right of 0? +1. And what's the slope at 0? Sharp turn, corner, cusp, DNE. The slopes aren't the same from either side. But is there an equation that we can use that will give us that? Well, let us see. I can't just take the derivative of the absolute value of x, but if I write it as the square root of x squared, now I have some exponents that I can work with. And here's the thing. You want to have a high emotional quotient. You want to avoid or resist the urge to simplify, right? Because 2 to the 1/2 power, when you multiply, gives you 1, but then you're just stuck with x, and its derivative is 1, and that doesn't work. So keep it like this, and now use the chain rule. How many layers do we have? I see 2, right? Blob to the 1/2 and the blob. So it's going to be 1/2 blob to the -1/2 times the derivative of the blob. What's the derivative of x squared? 2x. And if we simplify that, let's see, this 1/2 and the 2, they divide out, and we're left with an x over, that goes back to the bottom under square root. Well, now I can replace the identity back. What is the square root of x squared? Absolutely, it's the absolute value of x. And now we just came up with a function. The derivative, if y equals the absolute value of x, the derivative function is Signor Salta, which we know also works the other way around. Jumpman is the derivative of the absolute value of x. Makes sense, right? Yeah, makes sense. It doesn't exist at 0, and it's just 2 horizontal lines to the left and right, +1. And I got it backwards. That's negative f of x. That's negative f of x. Yeah, let's do it the right way. There we go. It's +1 to the right of 0 and -1 to the left. All right, that concludes the chain rule. The derivative of Jumpman, you could do that. That might be something to try in the privacy of your own home. I mean, what would you do? You would call it the square root of x squared again, right? And then you would use the chain rule with the Hody high rule and then replace it back in there. Yeah, it's kind of interesting. I would encourage you to do that. Maybe we'll warm up with that on, not tomorrow, because tomorrow's go to the dentist day, Thursday. So the worksheet will be due on Thursday, not tomorrow. Tomorrow's Wednesday. Tomorrow is Digital Citizenship Awareness Day. It's the PSAT NIM squat test. It's the ASVAB. It's all that good stuff. So Thursday, the worksheet's due. And then when you come to class on Thursday, we're probably going to have to quiz over the chain rule. But it should be short and easy, and for sure fun, as always. What's that? You want to do a group quiz? I'll let you have a group quiz on Thursday. I'll make it a little more challenging, but I'll let you work with some people.